Hey guys, I wanted to take a quick look at the Unreal Engine 5 Reveal video so we can analyze the new features and discuss what this means for developers using Unreal Engine. Quick disclaimer, I am not affiliated with Epic Games and much of what I discuss in this video will be speculation. Okay, let's take a look at the Reveal video.
This has to be the right way.
Before we continue, let's stop a moment and take a look at some of the key features of this demo. Much of what you see was built with Quixel Megascan assets, but instead of using the game versions, we used the cinematic versions, which would typically only be used in film. There are around 1 million triangles each.
Wow.
And thanks to virtual texturing, they all use 8.
Okay, so 1 million triangles. I'm assuming they're talking about each rock. You can actually go out on Megascans, and we'll do this later, and look at the assets they're using. They are huge. How are they doing this? This is crazy, right? Well, not really. Let me show you what this most likely is. So this didn't get a ton of recognition back when it came out, December 18, 2018. This is from NVIDIA GameWorks, and it was kind of overshadowed by all the cool ray tracing stuff they were doing with the new 20 series cards, but I have been wondering when this is coming, and I think this is what we're seeing. Let's take a quick look at this NVIDIA mesh shaders demo. Mesh shading. Geometry processing unleashed. See, same kind of thing they're talking about, big numbers. Let's take a look here at the numbers we're talking about. Let me get it stopped at a better spot where we can read. Okay, so total asteroids, 264,324. That's a lot of asteroids. Drawn triangles, 47 million. That's not that many. That's not crazy. You know, it's 47 million. It's not crazy. But look at this, max LOD triangles. So what they're telling you, and you're going to see this a second in the Unreal Engine 5 video, they're going to talk about source triangles. Okay, so you got to realize there's a difference between source triangles and rendered triangles. So what we're seeing here in this mesh shaders demo from NVIDIA, we are seeing million, billion, trillion, 2.7 trillion source triangles. Okay, they're not being rendered. 47 million are being rendered, but there's that many source triangles. What's happening here is that historically, the way that game renderers work is that you keep these different LODs, which are your mesh vertices, in system memory. And you've got LOD0, LOD1, LOD2, LOD3, whatever it may be. And you're sitting there swapping them out every frame, right? You're calculating the distance to it, and you're like, okay, on this frame, I need LOD1. Send that to the GPU and render it. Okay, on this frame, you got closer, I need LOD0. Send that to it, right? And doing that, it just, there's only so much you can do. You know, draw calls are a big issue. It just, you're constantly moving memory back and forth. So what they're doing here in this demo is they're actually saying, well, why don't we just load the source mesh right onto the GPU, right in GPU memory. And then we will use a mesh shader, right? Vertex shaders, pixel shaders, or it's probably a vertex shader or some type of, something like that. And we're sitting there doing the LODing. LODing here is the case of going from 2.7 trillion to 47 million, right? All being done on the GPU, right? So this completely, the system memory is not connected to this anymore. It's all just running on the GPU. The numbers are drastically going to go higher. And if we take a look here, we will see
textures as well.
We'll talk about the textures in a minute. So they call it Nanite.
Very quickly. There are over 1 billion triangles
okay,
of source geometry.
Here we go. 1 billion triangles of source geometry. Okay, right? Seems like a ton. Well, not really. We got 2.7 trillion here, right? It didn't really matter the source ones as much. It more is going to matter the rendered. And they tell us what that is.
Frame, that Nanite
okay, there we go.
Losslessly to around
20 million drawn triangles, right? Okay, well that's kind of cool. I say this looks awesome, but we had 47 million here. 20 million is not that many. It's not. It's not that many triangles. So I think this is what they're doing. I'm pretty sure that Nanite is some kind of implementation of this mesh shaders, which it's going to be huge. It's going to be massive. It's going to save us as developers tons of time, particularly those who work on the art pipeline.
Million drawn triangles. What does that many triangles look like? This isn't noise. These are the triangles, each a different color. Most are so small that they look like noise. Nanite achieves detail down to the pixel, which means triangles are often the size of pixels. This amount of geometric detail requires shadows to be pixel accurate as well, and Nanite can do that too. Speaking of lighting...
Okay, before they talk about lighting, let's talk about, they said they're using 8K textures. How are they doing this? I mean, you use 8K textures, it only takes a few of them and you're going to run out of your video memory. How are they doing it? Well, we already have that. It's called virtual texturing. It's already in UE4. They have runtime virtual texturing, which works well for landscapes, and they have streaming virtual texturing, which is probably what is being used on these rock assets. It is a better version of the old MIP mapping. So with MIP mapping, they would have various resolutions of your textures, and just like LODs would swap in and out, they would swap in and out. UE4 has something called texture streaming, so that it's always trying to keep the right resolution of each texture in memory. But this virtual texturing goes beyond that. I'm pretty sure this is what is powering the ability for them to use these 8K textures on all of these many assets.
All of the lighting in this demo is completely dynamic.
So
with
they
the
told
power
us
of
it's
Lumen
dynamic.
That even includes multi-bounce global illumination.
That is huge.
No light maps, no baking here. Without GI, all of
Th-
that beauty...
There we go. So now they showed us. So if I were to go in Unreal Engine right now, which I can go do this, and I could go build this scene. I'll show you later where you can get all the meshes. You could go build this scene in Unreal Engine right now. Nothing stopping you. Well, we'll see later what's stopping you. But it would look like this. This is what it would look like. It looks terrible. This is one of the biggest problems for dynamically lit games. It's just, what we end up having to do is we have to fake it. We just kind of go, well, in this certain spot here, there's a certain amount of just ambient light. And so we unrealistically just light everything else evenly. And this is going to look so much better.
With Lumen enabled,
Look at that.
move the light and the bounce changes instantly.
And it's changing in real time. Now, it's hard to say whether real time here means actually per frame, or if this is being done asynchronously in the background, and then when it actually calculates the values, it's then updating the lighting. So we don't know for sure on that. I think the biggest question on this that I have, is this RTX only? Is this a general solution that doesn't require RTX ray tracing but works better with ray tracing? I think that based on some of what I see here, I think that at least in this case of the PlayStation 5, I think that it is using some kind of ray tracing to do those shadows. That's just a speculation, but I think it is. So ray tracing is built into DirectX. It's not like NVIDIA only with RTX. NVIDIA can have their implementation of it. AMD can have theirs. It doesn't matter. But I think that this is probably factoring into it. But what we don't know is if there's a general purpose solution. For example, Unity has used this system here called Enlighten. And you can see here, very similar to like when they turned it on and off over in this demo here. You can see the same kind of thing here. It's either just get the black because you're not getting the bounce lighting, or you get the bounce lighting. This was a solution that did not use ray tracing, a general purpose. So it's very possible that what we're getting here with Lumen is one of those general purpose things, but I would be surprised if it's not making use of RTX in some way, and specifically in this scene we're looking at. I also saw here that when I was looking up Enlighten, that I guess Enlighten is getting replaced in Unity. So it says Enlighten will be replaced with a robust solution for baked and real-time global illumination. And I think it was some kind of licensing thing. But they're saying that they're going to have a real-time GI replacement solution to be delivered in 2021. Probably a general purpose solution. I don't know. Hard to say. Maybe it's RTX only. My guess is the same type of thing as what Epic's doing here. But this is huge for us doing dynamic lighting, day-night cycles, open world games. This is what we've been waiting for. In our game specifically, it's a problem trying to get. We can either get the lighting outdoors looks good or the lighting indoors looks good, or we can't get both. But we can't get both at the same time. It's going to fix all that. It's going to be awesome. I cannot wait.
Okay, let's keep going. We've made some great additions to our audio system as well. Convolution reverb allows us to measure reverberation characteristics of real spaces, like actual caves that we sample, and reproduce them in virtual spaces. Sound field rendering allows us to record and playback spatialized audio.
This stuff's already in Unreal, so it's not a huge thing. Maybe they're making some improvements to it,
Up to a
but
more immersive experience.
nothing new. Everybody's calling this the Final Fantasy VII Remake loading screen. I don't think it's actually a loading screen here, guys, but I have heard that people think that it is in the Final Fantasy VII Remake. I don't know if that's true or not. But I don't think it is here.
Bats was created with our Niagara effects system. Particles in Niagara can now talk to one another and understand their environment like never before.
I don't think that's new. I think that's what Niagara already does. Niagara, as we'll see later here too, Niagara was all about, we want effects to be more dynamic. We don't want them to be these static things you just play. We want them to be able to change as the scene changes and respond to events in the game. So I don't think that's really new.
We've also added a ton of new functionality to run fluid simulations like you see in the water below.
Yeah, it's kind of cool. Nice that it's built in, I guess.
The demo runs on our chaos physics system. Here we are using it to accurately simulate the rigid bodies of the falling rocks and the cloth of her scarf.
Okay, if we stop here... Nope, didn't stop at a good spot. Okay, so you can see this, this rock here with these different cracks and stuff. So I was like, well, let me go try to find that rock, and let's take a look at it and kind of figure out what they're doing here. So I went over to Quixel Megascans, and this is this limestone query set that they're using. And all this stuff's free for Unreal Engine developers for use in Unreal. And so I found that it was this one right here. It was the cracks there. They had the blue paint on some kind of decal, but this one matched what we had over here, that piece there. And so I downloaded it, loaded it into Blender here, and you can see, now this is the, let me show you how I had to do this, because it didn't do it by default. So when you come here to download it, you actually have to go to download settings, and you have to put in this high poly source. If you don't do that, you'll just get the game LODs. You won't get the original high poly source. So these are all like really low poly game stuff, and they have a normal map. This high poly source is the original scan. I'm sure cleaned up, but the original scan. So I pulled it in here. You can see it has 2 million verts and 4 million tries. I mean, this thing's massive. And so we pull that into the game here. I've actually pulled 3 of them here into an Unreal Engine 4. And, I mean, look at that. 18 frames per second just for dropping 3 of these on here. I'm running an 8700K with 64 gigs of RAM and a 2080 Super. So it's a pretty high-end PC. I mean, it's killing it. It does not have that mesh shader stuff, right? It's not reducing it. It's rendering all those 4 million tries each. So that's it's 12 right there. And you can see if I remove them, you know, I normally get over 200 frames per second when I'm rendering a blank scene like this. So it's expensive. It's but you know, that's how you get all the detail. You know, all of these, there's no normal maps going on here. These are actually self-shadowed, the shadows against itself. You know, if you look at the material, all I pulled was the albedo and the roughness. No need for normal, no need for ambient occlusion. These technologies, you know, with the new system, just not needed anymore. So, cool stuff there. Oops. I gotta say, props to the level designers here. There's not that many unique assets in this level,
Now that the
but they
environment
do
is
a
so
really good
complex,
job
we
of
use
making it
great
look like there
intuitive
are.
animation systems to adapt.
You would be surprised if you
We've added
if you
predictive
looked at it and were
placement
like,
and motion
hey, so how
blur
many
that
rock assets did
dynamically
you use? It's
modifies
like,
eye
oh, we
movement
used
and body
like, 5 or
position to
6.
look
And you're
more
like,
natural.
how?
For the
It's
characters to
more
more
than 5 or
realistically
6, but
interact with the
it's not what
environment,
it looks
we've
like.
added the
They're
ability to trigger seamless
really
and
good
tasteful animation
level
events,
designers.
like her hand on the door.
That's promising.
So this is kind of cool that it's built in, but anybody who wanted this was adding a system to do that anyway.
Dynamic
So
GI is amazing, not just for speeding up iteration, but also for its impact on gameplay.
Lumen's going
Any
to be
light source
awesome
removed will
for
still have a
torches in
beautiful output.
caves,
Dynamic illumination
anything like that.
means specular as well, which you can see on all the metal surfaces.
It looks great.
You can
It
even
looks
see the
like
Niagara
ray
powered bugs
tracing.
reacting to the light.
So there you saw
Lumen not
also that the bugs were just a particle system, which means they could render a lot of them really cheaply. But they were reacting to the light. So again, that's really cool. That's the kind of stuff that Niagara can do. You can do that right now in UE4. But the real-time GI here for indoor spaces that are supposed to be full dark, but you're moving around a light, it's awesome. It's gonna be so cool.
not only reacts to moving light sources, but also changes in geometry.
Once you're not baking lights, you can move things around more and not have to worry about
Remember
things.
we mentioned high poly assets? This statue was imported directly from ZBrush and is more than 33 million triangles.
Yeah, 33 million. So this is cool that they told us that they came right from ZBrush. So that's not normally what you would do. Normally you do your ZBrush sculpt, you would do your remesher, you'd get your low poly, then you'd bring it into something like Painter or some other tool, you'd do a bake, you'd get your normal maps, your AO maps, you'd have now a low poly asset, and you have to do all this other work. They're saying, hey, we just brought it right in from ZBrush. So this should be a massive time savings. Again, it's not rendering 33, they say million? Yeah, 33 million. It's not rendering 33 million. But it's doing the work in the mesh shader to lower the count of what it's actually rendering based on distance and other factors. So it's pretty cool.
No baking of normal maps.
There we go.
No authored LODs.
No authored LODs, no baking normal maps. I mean, that's where we spend a lot of time. It looks great.
And we can do more than a single statue. There are nearly 500
Wow.
of that exact statue at the same detail level placed in this room, for a total of over 16 billion triangles
It's a lot.
statues alone.
Again, that's source triangles. So we had 2.7 trillion in
Over
the
this entire
asteroid demo.
there are hundreds of billions of triangles. So with Nanite, you have limitless geometry, and with Lumen, you have fully dynamic lighting and global illumination,
Wow.
all running on a PlayStation 5.
That's the crazy part, that this runs on a PlayStation 5. I mean, imagine what it's going to look like on a high-end PC. You know, you're spending, say, $500 for a PlayStation 5. You know, my PC was $2,500 without monitor. So I can't imagine what it's going to be like on a PC.
There's not much time left.
And this doesn't need to be constrained to small rooms. It can stretch all the way to the horizon.
So one of the guys on my team, the first thing he said when he saw this, and I think he's right, he said, "Oh look, they picked a desert scene. That was on purpose." So if this is using ray tracing like we think it is, one of the current problems with the ray tracing implementation is that it does not do foliage well. So what's a good way to not have a ton of foliage? Desert scene. So I think it was strategic that way. It still looks awesome, but it will be interesting to see if we could have put a forest in the background with this still run. I don't know.
The portal, it's open. Don't fail me now.
So what this is showing that's really good is how they're able to use that virtual texturing to stream the textures in and out at the resolutions they need very, very quickly. Because, I mean, look at how fast they're moving through this scene. And now, again, there's some motion blur and stuff, so even if it was a little late on getting the right resolution of texturing, you might not notice, but it's still very, very impressive to move through the scene that quickly.
It's time to see what's next.
Coming 2021. So I think I saw somewhere it said mid-2021. So what does this mean for developers? So the first thing we have to decide is your game project going to switch to Unreal Engine 5? So you kind of have to figure out when your launch is. And the good news is it sounds like there is going to be an upgrade path. And I think it was stated that it wouldn't be all that different than upgrading from one version of Unreal Engine 4 to another. So it kind of makes sense. I don't think this is the groundbreaking rewrite of the entire engine kind of thing like it was moving from UE3 to UE4. It was quite different then. I think this is more just a leap from Unreal Engine 4 to Unreal Engine 5. Obviously, two huge new features in Nanite and Lumen. Those are going to be awesome. But I think Unreal Engine 5 is going to seem familiar. And luckily, they've told us there is an upgrade path. So depending on when your game launches, might make sense to move to Unreal Engine 5. If that's the case, what does that mean? Well, we can definitely worry less about our vert count on models. A lot of times that's been a big question of like, okay, I've got this rock, is 20K too high for LOD 0? Do I need to make it go down to 15K, 10K? And you really have to worry about these sort of things. The current workflow is pretty strict for your adherence to your vertex budget. Every asset has to be tuned for just the right vertex count for each LOD. Distances for every LOD have to be tuned perfectly. We have to minimize pop while keeping our vertex count low. There's a lot of work, and based on what we see here in Unreal Engine 5, a lot of this painful work looks like it's going away. So that's really great. When you're doing your high to low poly bakes currently for stuff in UE4, make sure you keep all those high quality versions. You probably already do, but make sure you got all those because probably going to switch back to those when we go to Unreal Engine 5. So definitely keep that in mind. Modify your art pipeline to be looking forward. Don't spend too much time worrying about normal maps and ambient occlusion maps. This is a big thing in Unreal Engine 4. Can add a lot of detail, allow you to have lower vertex counts. But I think that the way they're moving in Unreal Engine 5 with this high poly workflow, I think a lot of those maps are going to be obsolete. I just don't think you're going to be generating normal maps and occlusion maps and doing the high to low poly bake that we've been doing for nearly 20 years. That's changing. So that's going to be awesome. It's going to be great. Tools are going to have to change to handle this as well. Don't spend months working on the perfect lighting model. Right now, especially if you're working on an open world game, lighting is so difficult. There's so much work in trying to get it to work well, mix indoor and outdoor, and get around that issue of all your shadows being too dark and all these type of things. But if you're planning on moving to Unreal Engine 5, maybe that's not where to focus your time. Lumen should help you out there, and so I wouldn't spend months agonizing over getting the perfect lighting model. Get something decent, and then wait for Unreal Engine 5. But definitely hold off on optimization. There's a good chance that if you optimize for Unreal Engine 4, it's going to be wasted work in Unreal Engine 5. So I'd hold off on optimization. Obviously you're going to need things playable to do playtesting and things like that, but a lot of times you can do that with stand-in assets. So I would definitely not prioritize optimization if you plan on moving to Unreal Engine 5. And finally, this is the big one here. Dream bigger. Dream bigger. Nanite and Lumen are going to make so many things we could only dream of before possible. open world games are getting a huge boost in Unreal Engine 5. I'm super excited. This is going to be great. It's so exciting to see what they're doing. When Unreal Engine 4 first came out, and I was using it back in 2014, I wanted to do open world type games, and there wasn't a lot to work with. We didn't have world composition yet. Dynamic lighting didn't work well at all. There were just so many things, and to see them moving this direction with Unreal Engine 5, prioritizing Nanite and Lumen as the two main features, I mean, they're positioning it for open world games, and it's going to be great. So let me know in the comments what features you're most excited for and how you plan to use Unreal Engine for your game project. Thanks.